some people who were in who were in let's go back this way. Let's see. Hopefully it'll recognize the camera. Because of the issues we were having with Zoom, which looks like we may end up having the same problems with Zoom. Oh, that's not what I was looking for. There's supposed to be a camera app in here. Oh, that'd be sucky as hell. Trying to get to see if I just can't get it to show up. In hi. Yeah. Yeah. Mm-hmm. Yeah. Man, it's not showing up. All right, I'm gonna have to. I understand why this issue hasn't been brought up to IIT because evidently I'm the only professor who signs into the computer in here. So I'm the only one who uses the camera, and Zoom doesn't recognize the camera. It doesn't show that the camera is there. So I don't know if it's. Oh. That's something I haven't. There it is. When I cuss.
Oh, when he cusses, yes, I will interpret that.
It was there for a second. Still not doing it. I'm frustrated.
So I just want to remind you real quick, that was the one that emailed you about the access code. I think I'm down to like 2 days now on temporary access.
Okay, let me see here 1 second. Can you talk again, Tyler? I didn't hear you.
I just want to remind you that I'm the one that sent the email to you about the access code not working for me. I'm down to like 2 days. So I just want to let you know.
Okay, you have the temporary access?
Yes, but I think I have like 3 days now, 2 or 3 days.
Okay, yeah. I'm gonna email my department head tonight, and she's usually pretty good about getting the stuff to me pretty quick.
Okay, thank you.
Where are we? Did we get to the fundamental identities, the Pythagorean trig identities? And so we covered the slide. Let me pull this slide up. And we'll work from that. So we covered this slide. Yeah. Okay. Yeah, people in Zoom, please be sure you pin my screen and maximize the screen size so you can at least be able to attempt to read everything on there. All right. And I know why it's not advancing. So we did the letter A and B. Or letter A being 0 and letter B being 1. And we did this one as well. Okay. Yeah, there are a couple of ways of doing these. One way is determining the what R is, and then build it up that way from there. Yeah, but the way I did it, the way the textbook does it, is a little different. The textbook says, okay, we have sine of theta equals y over r, which is 1/3, which means y equals 1 and r equals 3. And so the equation of a circle is x squared plus y squared equals r squared. I know two of the numbers, so I can find the third one. And so x squared plus 1 squared equals 3 squared, which is x squared plus 1 equals 9. And so x squared equals 8. So x will equal, and we determined that cosine, which is what x is going to be negative. And so that's going to be the square root of 8, which is the negative 2 times the square root of 2. Actually, this is actually the simplified form of the square root of 8, if you can believe it. Okay. And so cosine, the cosine theta was negative. Well, cosine theta is x over r. X is a negative 2 square root of 2, and r is 3. So that's what cosine is. And then cosecant is the reciprocal of 1/3. Secant is the reciprocal of cosine, and then you would rationalize the denominator. And then tangent is y over x presents here. So it's 1 over negative 2 square root of 2, and then you simplify the denominator. I mean, you rationalize the denominator, multiply numerator and denominator by the square root of 2, and you wind up with this number here. And then cotangent is the reciprocal of tangent. Well, they use this fraction instead of this fraction, because when you do the reciprocal of this, the radical's in the numerator. It makes it an easier problem to solve, rather than doing the reciprocal of this and then rationalizing the denominator, and you still end up with this. Okay. All right. Did we do this?
We've used it. We've used that theorem.
Yeah, this is the Pythagorean, one of the Pythagorean identities. So we could use the Pythagorean identity to, well, we kind of used it already here, but we can use it again in a different way. So we're going to say we're gonna solve for cosine. That means we're gonna subtract sine squared from both sides.
We're not gonna do that.
Why?
To keep the cosine, to have the cosine on its own. To,
But why divide?
because that's how we, isn't that how we do?
I wanna get this away from the cosine.
It doesn't, don't
So
we
I
divide?
subtract
Oh, okay.
because we're combining, so I wanna do the opposite. I want this to go to 0. So I subtract it, so I have to subtract it from the 1. And we get this. And then we want to find out what cosine is. And we already decided that cosine for this problem is negative. So when I take the square root of this side, it's going to be the negative square root. Well, typically, we usually write the plus or minus, but for this particular problem, we want the minus, the negative square root of 1 minus sine squared. Yeah.
We decided it was negative. Hold on, first one, right?
Yeah, because they said, what was it? I'm gonna back up. Yeah, cosine is negative. And the sine is positive. So that put us in the second quadrant. Right, that put us in the second quadrant. So now we know sine is 1/3. So I'm going to replace sine squared with 1/3 squared, which is 1/9. And 1 minus 1/9 is 8/9. We take, and the way square roots work, we take the square root of the numerator and divide it by the square root of the denominator. Square root of 9 is 3. And the square root of 8 is 2 times the square root of 2. Does anyone want to see how we get 2 squared to 2 from the square root of 8? Okay. So the square root of 8, I can rewrite this as the square root of 4 times 2. If you look at the number that you're taking the square root of, and a factor of it is a perfect square, then write it as a product of that perfect square times whatever number. Because now I can rewrite this as the square root of 4 times the square root of 2. Well, we know what the square root of 4 is. 2. And square root of 2 stays square root of 2. So how I used to say it, I pull out, you pull out your square roots. So this is why we can do that. And I've dealt with square root of 8 so much in my head. This is 2 square roots of 2 in my head. But this is how we do it. I didn't. This isn't one of the things one of the things I used to tell my students. I haven't done it this semester. Know the first 16 perfect squares because it comes in handy. You know the first 16 perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, that's 13 squared. 196, that's 14 squared. 225 is 15 squared, and 256 is 16 squared. I can do it better. I can do it faster if I'm writing them down. But and those show up a lot in math classes. So as long as you're taking a math class, it's good to have those residing in your head. The first 6 perfect cubes show up a lot. 1 cubed, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 115, and 6 cubed is 216.
Is to the third power?
Yeah. And 7 cubed, I'm not sure on this one, but I think it's 343.
Yes.
Yeah, it is 343. For some reason, I want to say it's 483. but it's not. And then to the fourth power, there's 3 of those. 1 to the fourth, 2 to the fourth, 2 to the fourth is 16, and 3 to the fourth is 81. You don't usually see 5 to the fourth, but 5 to the fourth is 5 squared squared, so that's 25 squared, which is 625. Did I say I play with numbers all the time? Okay. I have. Probably not here. Because there's too many full-time professors who like teaching calculus, so us lowly adjuncts don't get it. Yeah, and I just informed yesterday my department head that I've taught intro to statistics several times, and I actually enjoy it. Although I hate the subject of stats, but I still enjoy teaching intro to stats. Spread around the pain. Okay. But she may be using me for that for a while, because they had to drop sections this semester because they didn't have enough teachers teaching. Yeah. And they were full classes too. Okay. This class shouldn't have made. Because there's only 13 people in the class. We needed 17 for it to officially make. Because they were desperate for teachers teaching certain classes. And they said, if you take your schedule this way, you can have this class, this under-enrolled class. I said, okay. Otherwise, I was going to have 4 classes back to back on Monday, Wednesday, at 8 o'clock, or 10 o'clock, at 12 o'clock, and at 2 o'clock. So 4 4-hour classes all in a row. Yeah. They didn't do that. And then, and yeah. And, but no, the 3 in a row is killing me now. 3 2-hour, 3. They're an hour and 40 minutes long. Oh, like this one. And this morning I had an 8 o'clock, and that's a 2.5. That's a 2-hour class. It turns out to be a 5-hour class, but it's 2 hours and 10 minutes per class. It's a 13-14 class with a co-rec that goes with it. So it bumps it from a 3-hour to a 5-hour. 13-14 is a free calculus, college algebra. The 13-14 version of college algebra is usually called a terminal math class, meaning it's the only math class you need to take for your major.
Yeah, so it'd be someone like who doesn't really know that.
Right. Like I know all the cosmology students have to take. They have to take 1 math class. And 13-14 is one of the classes that they can take. They can also take intro to stats. They can also take intro to stats used to be a 4-hour course. Now it's just a 3-hour course. Ooh, I'm used to the 4 hour. Anyway, back on. Okay. So, and then they talk about using the quotient and reciprocal identity. Tangent is sine over cosine. And so this simplifies the 1/3 go away. So it's going to be 1 over the -2 squared to 2. And then rationalizing the denominator, we get the same tangent we had before. And then cotangent is the reciprocal of this. Cosecant is the reciprocal of this. And secant is the reciprocal of this. That's what I usually use. Once I have one of them, to get the reciprocal function, I just flip the fraction and simplify. Yes.
Spell secant for me, I think I'm spelling it wrong.
Secant.
Mhm. Secant.
And it's usually, we just usually use the SE. I've had students, especially in high school, who don't pronounce this as sine, they pronounce it as sin. And it bothers me because it goes against my OCD. So. But no one's ever called cosine cos. And you got corrected.
No, he was upset.
Yeah, well, that's his issue. Okay. And yeah, and so they did reciprocals to get the cotangent, the secant, and the cosecant. They did the reciprocals. Given the value of one trig functions and the quadrant, the exact value of each of the 5 remaining trig functions can be found in either of 2 ways. Well, actually, I did another way. So you have 3 ways you can do it. Where I didn't use this fact. I just said that sine was 1/3, and so that means that's the y value. So if the x squared plus y squared equals 1 squared. So that's going back to the unit circle. Because I'm dividing by r. And so we have 1/9 equals 1 and x squared, and you wind up getting that x. That x is this, which is what cosine is. So that's one way of doing it. I've been told that that's the improper way of doing it, if it works, so I don't see a problem. But it's an argument I have with someone on a regular basis. And then the 2 ways they show, which is using that sine is y over r, and we find out what r is and what y is, and then we can find out what x is through that. And well, yeah, using the circle radius r, and that's using this method. The first one they showed us. Okay. And yeah, so they're going through the steps here. And the other way is using trig identity. Uh-huh. Well, if we're looking on the unit circle, the sign is what y is. But if the circle doesn't, that's if it's, the circle has a radius of 1. If the circle has a radius of r, then it's r sine theta equals y, and r cosine theta equals x. And then you just divide by r in both cases and get sine theta equals y over r, and cosine theta equals x over r. Because then you just divide both sides by r, and you get this one. That's when the radius of the circle is other than 1. Okay, right, the radius here is 3. And I just said, well, what if the radius is 1? Then I would use this as y, and then I can still use the same equation for a circle, but with the radius being 1 instead of the radius being 3. Well, I'm using the when I did it, I used the fact that sine theta equals y when the radius is 1. When the radius equals 1, because this is still y over r, with r being 1. With r being 1, we have this. And so saying that y is 1/3 would be the same as saying y is 1, but the radius is 3. How we put it into the problem. It all works out. Okay. Right, now using the identities, using the appropriate identities, find the value of each of the remaining functions. Okay, given that the tangent is the square root of 3 over 3, and sine is less than 0. So sine is less than 0 means we're dealing with the third and fourth quadrant, right? Sine is only positive in the first and second, so sine is negative down here in the third and the fourth. Cosine is a positive value. So that means tangent is a positive value. So we're dealing with the first quadrant or the third quadrant. Well, they're both the third quadrant meets the criteria. So whatever angle we're dealing with, it's going to wind up in the third quadrant. Okay. Now, doesn't matter what the radius of the circle is, tangent is always y over x. So we're saying this is the square root of 3 over 3. So x is 3 and y is the square root of 3. That's what the point out here with whatever it is. So now we just need to find out what r is. And once we find out what r is, we can find all the other trig functions.
Cotangent would be x over y,
Right.
correct? Okay.
So cotangent, yeah, cotangent's easy. So I can cotangent of theta, I know is going to be 3 over the square root of 3, which winds up being the square root of 3. Dividing 3 by the square root of 3 gives you the square root of 3. Because the square root of 3 times the square root of 3 is 3. So now I'm gonna put this in the formula, x squared plus y squared equals r squared. So I can find out what r is. So now I have 3 squared plus the square root of 3 being squared equals r squared. Oh, I gotta stay out of the way of the camera. Oh, so now we have 9 squared. 9 equals 3, plus 3, sorry, equals r squared. Or we get 12 equals r squared. And then taking the square root of both sides, we get r equals plus or minus the square root of 12. The radius is a length, and length is constant. So yes, so this is just going to equal the square root of 12. Well, 12, I can get 12 by multiplying 4 times 3. So this becomes 2 square roots of 3.
Could you repeat that for what you said about length and positive?
Length is always positive. When we talk about negative length, we're talking direction with respect to a reference point.
Radius always spurts out of the
Right.
origin.
The radius always comes from the center. In this case, our center is always going to be the origin. Because I could have a circle up here. But if I move the circle down over here, then I don't have to worry about the center.
Sine is r over x.
What is sine?
Sine 1 over cosine. The reciprocal identity.
Y over
Oh,
R.
y over. Okay. I just know.
And what is cosine?
R over.
X over R. Cosine and Y are X and Y. When you have a radius other than 1, then it's X over R and Y over R.
So
Cosecant, yes, it's going to be the reciprocal of this. The reciprocal of this, and secant is going to be the reciprocal of cosine. Okay, so sine is y over r. Sine y, what was y? Y is the square root of 3. And r, what do we say r is? Oh, 2 square roots of 3. So the square roots of 3 go to 1, and so that leaves me 1/2. So sine is 1/2, which means that cosecant is 2, because the reciprocal of 1/2 is 2. Cosine is x over r. X is 3, and r is 2 square roots of 3. Going to multiply numerator and denominator by the square root of 3. So we get 2 times 3, and 3 times the square root of 3. So the 3 in the numerator, 3 in the denominator. Those go to 1. So this becomes square root of 3/2. And then the reciprocal of that is secant. So we're going to get secant is
R over x. 12 over.
All right, R over X. R is 2 square roots of 3, and X is 3. So we're done. And did we do cotangent already? Okay, so here's 1, 2, 3, 4, 5, the remaining 5. Now realize when we're dealing with the trig functions, there's generally more than one way to do it. Because of all the different formulas. Okay, so using a circle. And they say the point XY, which would be this point here, is in this quadrant. And they determined that Y is -3 and or X is -3 and Y is negative square root of 3. So they approximate where that point and show that relationship there. I don't like how they did it. Anyway. And then, yeah, notice since tangent is X over Y, then you have a negative over a negative, which is the positive. This negative.
So, tangent is sine over cosine, right?
Sine over cosine.
So then X.
Or the and then they found out
But the area.
I
of the triangle-
just, oh, that's the radius. But this is the distance formula.
Distance, oh yeah.
So it's the distance from that point to the origin. The distance formula would be subtracting the X value squared plus subtracting the Y value squared. But since one of the X values and one of the Y values is 0, then you're just squaring X and Y and adding them together.
If radius equals the square root of X squared plus Y squared, that's the distance formula. X squared plus Y squared equals R squared is
The formula for the circle. So it's just taking the form, and that's what I did. Yeah, right here. I took the formula for the circle and I found out what X squared plus Y squared was, and then I square rooted it. I brought the square root in, and they already had the square root in the formula. It works the same way, just realizing that R is going to be a positive. So they got the same 2 square roots of 3. And then yeah, you have all the pieces to put together to form the trig. The trig numbers, because you know that sine is Y over R, and cosine is X over R, and cosecant is R over Y, and secant, I forgot the biggest here, is R over
X.
R over X, thank you. And well, the tangent we already had, but tangent is Y over X, and cotangent is X over Y.
So X is always cosine and Y is always sine. No
Yes.
ordered pairs.
Yes. So in the order of pair, it's X and Y, so it's cosine and sine. I have a tendency to see what cosine is first. And once you have those relationships, once you know what X, Y, and R are, then you just put them into the ones you're missing and simplify. And that's what the yeah, you just plug them into to these identities. Right, we already know what tangent was. And so cotangent just put them out. And then and the others are just putting them in the numbers in the appropriate places. And I need to quit getting in front of that.
So this, like the last one, they just give us tangent, which is 1 of x. So we can take 1 of the x and just do x squared plus y squared and get our r squared, and then square root that and get our r. But like
Yeah, just like what I did. That's from my point of view, that's the simplest one. It isn't. And then what I didn't do, I didn't take into account the signs of these things. This just reminded me. Sine is negative in this quadrant, so is cosine. So the sine's going to be negative. The cosine's going to be negative. That means secant is going to be negative. That means cosecant is going to be negative. And the tangent and cotangent are positive. That would be a -1 on a test. Yeah. Yeah. So the reference angle is the same no matter what quadrant you're in, but whatever quadrant you're in determines what the sign of the tree. It would make life easier, but life isn't that way. That's why I have 5 broken ribs. I play with numbers all the time. Sometimes it's easy, sometimes it's difficult, but it's always fun. Okay. And then the cosine and the cosecant and the secant and the cotangent. So they pretty much did it the same way I did. And so that's the first time that's ever happened. These formulas are right.
maybe it's because you've been doing it like all day.
No. No. It's just serendipitous. How does that work? All right. Now, because the value of tangent is known, use Pythagoras. Okay. So this is another way of doing it. Because using the Pythagorean identity that tangent squared plus 1 equals secant squared. So if I square the tangent, what was the tangent? I forgot. Square root of 3 over 3. So if I square this, and that gives me what? 3/9, and I add 1, which will give me 12/9 will equal secant squared. And so that's gonna be 2 square roots of 3 over 3 equals the secant. Because then you just do the square root of 12 over the square root of 9, which is 2 square roots of 3 over 3. This is going to equal. Wait. Yeah. Any questions here? So we got secants using a different method. We can use, what was the other one? 1 plus cotangent squared equals cosecant squared. Isn't that the other one? The Pythagorean identity. So we've got 3 Pythagorean identities.
Yes, that's one of the other thing, yes, cotangent squared theta plus 1 equals cosecant squared theta.
Okay, yeah, I tend to do that. So, but I don't see how I can use that. Well, cotangent is the reciprocal of tangent. So that means it's going to be tangent is the square root of 3 over 2. So its reciprocal is the square root of 3. So this is 1 plus the square root of 3 squared is going to equal cosecant squared. And that's going to be 1 plus 3 equals cosecant squared. So we have 4 equals cosecant squared. And taking the square root of both sides, and we know cosecant is supposed to be negative, so that's going to be a negative 2 equals cosecant. Oh, and this is supposed to be negative as well because it's in the, because of the quadrant for it.
So you got the Pythagorean.
Pythagorean.
And you wrote it down, that was the one we can use. Because I was trying to say like.
You can use, yeah, we can use it.
So, in that way, it's already number that is like. Different, or like a different way or another way. And it's number two.
It's all a puzzle. So it's just, what puzzle piece do you want to use next? Here, since I used Pythagorean identity, I went ahead and used the Pythagorean identity, but to use this one, I had to deal with the reciprocal of tangent.
Yes.
So I found cotangent by doing the reciprocal identity of tangent. Yeah, which is the square root of 3.
You plug that in.
I plugged it in. Square root of 3 squared is 3. So cosecant is 1 plus 3, which is 4. So cosecant squared being 4, that means cosecant is going to be plus or minus the square root of 4, which is plus or minus 2. And since we're dealing with this quadrant, cosecant is negative, so it's negative 2. Next.
Could you explain how you got from 4 equals cosecant squared to negative 2 equals cosecant? Oh, it's square root, right?
Right.
Square root, okay.
But this is going to be plus or minus,
Yes.
and then we have to take into account that cosecant is negative in this quadrant. And so that's why we forget about the,
You used the cotangent to solve the problem, but if we use the cosecant to solve the problem, we would also at the end, when we were left with just the number and the cotangent, would square root to find out what cotangent is.
Right.
Okay. Either one we use at the end, we square root to find. Okay. Because it's squared, right? Okay.
and now from cosecant, I can determine what secant is. And using that tangent is sine over cosine, I can do cosecant to find out what sine is. And so sine in this situation is a -1/2. And so a -1/2 over x is going to equal square root of 3 over 3. So that's a case where you cross multiply and set them equal to each other and then divide. So you would have a -1/2 over x equals the square root of 3 over 3. I mean over 2, sorry. So doing the cross multiply here, you have this x times the square root of 3 is going to equal 2 times -1/2 is a -1. And so x is going to equal a -1 divided by the square root of 3, which is a negative square root of 3 over 3. Is that what we got for x? No, what we got for x was 3, wasn't it?
Yes.
So what did I do wrong there?
Yeah, isn't that the tangent?
I'm feeling something's gonna go wrong, so because.
Oh, square root of 3 over 3 here. Okay. So this isn't going to be 1. This is going to be a -3/2. So we have no, that's going to be 6. Is that right? Yeah, no, 1/2 times 3, so that's -3/2. And dividing by or multiplying by 1 over the square root of 3. But then that doesn't give me this. What did I do wrong? Okay. But yeah, let's see what they did. Tangent is positive, sine is negative. Lines in the third quadrant where secant is negative. And so yeah, that's what I did here to find that cosecant. That secant is the -2 square root of 3 divided by 3. And yeah, so they. Okay. So you take the square root of the numerator, take the square root of the denominator, and you make it negative. And then you simplify the denominator. Or rationalize the denominator, not simplify it.
Will be allowed to copy the secret real quick? Get the secret one.
Which one?
The secret.
This over here?
Yes, sir.
Okay.
You almost got it, sir.
Okay,
I get them.
so now we have tangent and secant. Cosine equals 1 over secant, so the reciprocal of that is cosine. And so we got square root of 2 over 2. Square root of 3 over 2 is cosine, and it's negative.
Well, yeah, that's what we had gotten before, wasn't it? Okay, so, and I was getting there with the way I had been doing it.
And cotangent is 1 over tangent. And we get the square root of 3. And using the quotient identity,
The quotient identity is that secant over 2 secant. Or sine over 2
Yeah.
sine.
So sine is the same thing as multiplying tangent and cosine together. All right, we got what cosine was, right? Cosine was a negative 2 square roots of 3 over 3, correct? And we multiply that by the square root of 3 over 3. Because tangent times cosine. And so square root of 3 times square root of 3 is 3. So we have 2 times 3 over 3 times 3, and it's negative. So this is a negative 2/3.
Secant is 2 times square root of 3 over 2. Secant is right.
That's correct, it's negative 2 square root
Oh,
of 3.
so what was
Yeah,
cosine?
Yeah. Secant is 2.
Negative.
So cosine was what?
Cosine would have been, it was negative 3 square root of 3 over 2.
so we're gonna do the reciprocal, which is 3 over 2 square roots of 3, which is the square root of 3 over 2.
So when you do the reciprocal, does the sine change?
No, the sign stays the same. Because when you multiply reciprocals together, you get 1. Negative reciprocals are when they're going to have different signs. Slope of perpendicular lines are negative reciprocals. That's geometry.
Yeah, space time.
Okay. So I flip this fraction to get this, and then
That's
I
our cosine.
rationalize the denominator and got this,
Which is a cosine.
which is our cosine. And so I'm going to multiply the tangent, which is 3 square root of 3 over what? 3? The tangent.
Square root of 3 over 3.
Square root of 3 over 3 times the negative square root of 3 over 2. And that will give me the sine. I get 3 in the numerator and I have 3 in the denominator, so those go to 1. So that's just a negative 1/2. And then the reciprocal of a negative 1/2 is a negative 2, which is what cosecant is. We're just playing with numbers. That's all we're doing is playing with numbers. But there's rules that we have to follow. And that's the mathematics. Is what are the rules? How does it govern what we do? Mathematics is actually a subset of life. All the great philosophers from the 1700s and even before that were also mathematicians.
Descartes. The guy who had the quote, I think therefore I am. Well, he's one who had the coordinate plane. The Cartesian plane. We have Cartesian product. That's good stuff. Okay.
Sorry, where,
This one? Oh, over here.
sorry, sir, the question you were pointing out before that, right? Previously? The one right at the bottom in the middle.
This one.
Yes, yes, correct. Okay, so, square root of 3 over 3. Is that a base table?
No, this is a negative. This is this one.
Yeah.
This is what cosine is.
Oh, yes.
We figured out what cosine is. Cosine's this. And so we know what tangent is. Tangent's this. And so if I multiply tangent times cosine, tangent times cosine, it gives me a negative 1/2. That's what sine is. It's a matter of keeping it straight. I probably should use the full equations when I'm doing this. Because this is so sine theta equals tangent theta times cosine theta.
Okay.
That was great, sir.
So tangent times cosine gives us 1/2. Because now when we multiply square root of 3 times square root of 3, we have 3 divided by 3 times 2. The 3's go to 1. And that just leaves us 1/2. It was a negative fraction. It's positive times negative is negative.
Sorry, I forget to get out of the way of the camera.
The cotangent is square root of 3.
Cotangent, yes. Because you flip the tangent, and the reciprocal of tangent, which is 3 square roots of 3. Well, that's just the square root of 3, right? What do I multiply the square root of 3 by to get 3? Square root of 3. That's like looking at 8. What? I'm going to use 4. What do I multiply 2 by to get 4? 2. That's one way of looking at division. Is what number do I multiply by what I'm dividing by to get the one on top? Well, what do I multiply this by to get 3? Well, square root of 3.
So everything cancels out.
That's how I see these things. No. If you multiply the square root of 3 times the square root of 3, you will get 3, because that's the very definition of what the square root of 3 is. The square root of 3 is that number when you multiply it by itself, you get 3. So if I multiply both sides by the square root of 3, I get 3 equals 3.
On the bottom of the square root,
Right.
You cancel.
Well, you wind up with 3 times the square root of 3 upstairs, and you have 3 in the bottom. You take out your 1. Square root of 3.
what if you didn't take out the 1? What if you didn't take out the 1?
But you're not, you would have 3 in the denominator.
Multiply both sides by square root.
Yes, yes. So we have 3 times square root. What if you didn't take out?
Then you get a -2 because you didn't simplify the fraction. Yeah, you simplify the fractions. Divided by 3. Yeah, you would. if you type this into a calculator, you would get the same decimal number as this. Because I'm multiplying it by 3 and then I'm dividing 3 out of it. It's easier to see it this way. If I did 9 times the square root of 9 divided by 9,
You're multiplying.
that's
and
still gonna give me the square root of 9, which is 3.
That's what we do when we cancel.
Divided by, no, 27. It'll be 3. If you just do this.
That's what you
this
do
is
when you
just
say,
the
that's,
square root of 9, which is 3.
that's the process.
Okay, yeah, that makes sense.
Okay, that's exactly what we're doing here. Okay, and y'all couldn't see that because I did it over there. Actually, I did it there and I can't see it. Can y'all see that?
No, sir.
Did you pin my screen?
Yeah, I have you on the full screen.
All right, no, pinning the screen is you go, whoops, wrong corner. You go up to this corner, move your mouse up to this corner, and where the 3 dots are, you click that, and one of the options there is pin. And so you pin my screen, and it takes over everything.
Oh yeah, I did that for you already.
Okay, and so, and then on the full zoom thing, the little thing up here in that corner, you have the line and then you have the little box and then you have the X and you click on the box. And then if you close the chat window, it makes it even bigger. But then you miss anything anybody puts in the chat, which nobody has done other than their names. Jeez. And then they did the cosecant, which is 1 over sine, got the -2. And with tangent, with cosine and secant and sine and cosecant, I just flip the fraction and then simplify. I don't worry about writing it this way. Because it's just the reciprocal. Because understanding what's going on here is not always easy. So here we have, oh, what does that say? Even odd properties. Even odd properties. Some of the half of the trig functions are even and the other half are odd. Isn't that right? Sine of negative theta. So if I have the sine of negative pi over 4, that's going to be the same as the negative of the sine of pi over 4. The sine of pi over 4 is this angle here. And this point is the square root of 2 over 2, square root of 2 over 2, and sine is the y value. And negative pi over 4 is going in the other direction. And so this point here is the x value is going to be the square root of 2 over 2, but the y value is a negative square root of 2 over 2.
So the sign of negative pi over 2 is the same as the negative of the sine of pi over 4. That's what this is saying. So the negative angle, the sine of a negative angle is the same as the negative of the sine of its positive. Or the opposite. This is more about talking about the opposite angle. You're changing signs. Where cosine, I'm going to use the same angle here. Cosine of a negative pi over 4 is the square root of 2 over 2. But cosine of pi over 4 is the same value. So so if cosine takes you into this quadrant down here, it's going to have the same cosine value as this up here,
Which is negative.
which is the negative of this angle. So if I have a negative angle here, it's going to be the same as the positive angle. And if I'm talking about the positive angle, then the negative angle is going to have the same cosine. Because we're going in the same direction in the x. Here with sine, we're going in the opposite direction in the y's. So that changes our sign. So this is going to lead us into the description of the reference angle. Reference angles are the first quadrant angles, and then the sign just tells you where you're going to be. That's the sign of the function. And cosecant follows the rules of sine, and secant follows the same rule as cosine. So sine is an odd function, where cosine is an even function. All right, when we start graphing these things, the graphs of the sine function and the graph of the cosecant function. Oh. Because if you do f of negative x and you get f of x, then that's an even function. And if you do f of negative x, but you get the negative of f of x, then yeah, this is odd. This is from this is from Alexandra. And I know that because I just got through teaching it in my 3 Alexandra. Okay. So the symmetry of these two functions, they're symmetric with respect to the origin. Right, so they have point symmetry, which also means if you rotate it 180 degrees, it looks exactly the same. And these two functions, since they're even, they're going to be symmetric with respect to the y-axis. And so you can fold it up and it'll line up perfectly. Or this side is a mirror image of this side. Yeah, I like cosine.
I did it. X and Y. You don't know why.
Oh, well, I wasn't making a joke, but unintentional fun. Those are the best. Now, tangent and cotangent are also odd functions. Because you're dividing an even and an odd function together, so you're gonna wind up with an odd function.
For our odd functions, our first ones, sine and cosecant,
Mhm.
that's all the same rules, and they are symmetric with respect to the origin.
Correct.
And then our even functions, cosine and secant, those follow the same rules, and they're symmetric with respect to the y-axis.
Correct.
But tangent and cotangent, those are odd functions, and they follow the x-axis.
They're gonna be symmetric with respect to the origin.
Okay.
But sine and cosine are sinusoidal functions. Because they undulate like this, so that's called the sinusoidal function. I can't spell it. Sine. Oh, I'm not even trying. I'm not even trying. Okay. Oh,
Sir, I found it. Found it.
what? Sinusoidal. Sinusoidal. So it's you don't pronounce it sinus, but you say sinusoidal. Yeah. Well, a lot of this stuff dealing with trig is Greek, so thank you, Pythagoras. And who else? Oh, it's fun. Okay. So the exact by so this is and you can use formula first. You don't have to memorize. The reason I know I have it in my head is because I teach it all the time. So this is the negative of the sine of 30 degrees, which is the same as the negative of the sine of pi over 6, which is a negative what? 1/2?
Yes.
No, or a square root of 3 over 2. No, it is negative 1/2.
No, yes, square root of 3 over 2.
It is square root of 3 over 2.
Yeah, 1/2 is the cosine.
Oh. For pi over 6,
No, it's pi over 3. Oh, no, I'm wrong.
30 degrees is pi over 6.
I was looking at 60 degrees. I'm sorry. But it's positive, sir. Oh, no, but it's negative.
But it's going to be negative because we're talking negative 30 degrees. And so that puts us in the fourth quadrant where sine is negative. And this one is going to be the cosine of pi over 3, which is also a positive 1/2. The sine of 30 and the cosine of 60 are the same. And cotangent.
Cosine over sine?
What?
Cosine over sine? That's what cotangent is?
Well, I'm gonna write this as the cotangent of 5 pi over 4.
5 pi being our sine and 4 being our cosine?
No.
No.
This is the angle
Okay,
This is what theta is. All right, remember the period? Period of cotangent, what is it? Pi. So this is more than one pi. This is 1/4 pi plus 4 pi. Actually, plus pi, sorry. 4 pi over 4. So that's pi. So I'm just looking at the cotangent of pi over 4, which is 1. So, yeah. So this is a -1. Right? It's a multiple of pi over 4. So pi over 4 for cotangent and tangent is 1. It's just which quadrant are we in? Okay. This will land us in the third quadrant where cotangent is positive, but we want the negative. Because this angle would land us in the second one. Right? One way we go like this, and the other way we go like this. So the original angle was this angle. So that's going to be the negative of whatever cotangent of this angle is. Because you're changing the signs in the y value. And then at the quarter angles, sine and cotangent and tangent are 1 and -1. It's just called a quadrant. So tangent here, it's going to be the same thing. It's going to be a similar thing where it's going to be the negative of the tangent of 28 pi over 4. 28 pi over 4 is 29. Oh, it's 29. Why do I write 28? Because I'm going to change this. 29. So that's the same as 28 pi plus pi over 4, right? 28 of them plus 1 of them gives us the 29. So we have 28 pi over 4 plus pi over 4. 28 over 4 is 7. So this is 7 pi plus pi over 4. And the period of pi is k times pi. So this is the reference angle, pi over 4. Pi over 4 puts us right here, 45 degrees. But we want the negative of the tangent of 45 degrees. So tangent is positive in that, but we want the negative of it. So it's like that. So letter C and letter D give us the same answer. Because C was in this quadrant down here, and D was in this quadrant up here, where sine and cosine have the same sign. Positive, but we want the negative of that. So it's going to be. Questions?
Why is pi over 4 the reference angle of tangent? What's the relation there?
Because our period is pi, and so we're multiplying pi by 7. And then we're going another pi over 4. So that means we're gonna go, what is that? 1, 2, 3 times around. 3 and then 1.
Pi over 4 equals,
And we wind up down here. Oh, we're gonna wind up down here. That's where we wind up. We wind up in the same quadrant. These are the same angles. The terminal side is the same. In the fourth quadrant. Because, yeah, 7, so, because that's 1 times, that's 1 plus 6. So that's pi plus 3 times 2 pi. So I go around 3 times and then I go to pi and then I come and then I go 1/4. So that lines up the same place that 5 pi over 4 just went boom right there.
Okay, so we
Where-
go around 7 times, like is that the period?
No. We go around 3 times. The period is pi.
Yes. All the way around here. Oh, yes.
So I do the period 7 times. So I do 7 half circles. Okay. So,
Which is 3
which is 3.5 full circles. So if I divide that by 2, then that's 3.5 revolutions. And then you go another pi over 4. And so that winds up the same place. Where this just goes straight to here. This one goes around 3 times before it goes. And that's why we talk about, that's how we talk about referencing. All right. They all have the same referencing, pi over 4. It's just which quadrant are we going to be in? So I find the tangent of that angle and determine where I'm going to wind up. And then I change its sign.
Oh. Okay, so pi over 3, pi over 6, and pi over 4, it's referring to these.
Yeah.
Oh, okay. Okay.
Memorizing the unit circle just helps tremendously.
Says the pi over 4, but that doesn't mean it's direct. This pi over 4. Go down 45.
Or up.
Yeah, but in this case, the tangent one.
Well, the tangent one. All right. The this part here tells me I'm going once, twice, 3 times around, and then another half. And then I do the quarter. Which is this angle.
5 pi over 1.
Does that make sense?
Yes, with the tangent one.
Well, the cotangent one just goes straight. It just goes straight to there. The tangent one, we had to make the 3 full revolutions before we wound up there.
Sir, we're getting -1 per time. Yes?
Yeah.
Okay, does this contradict the tangent is supposed to be positive with the quadrant statement? Well, we are in the third quadrant, no?
Right, yeah, we are in the third
We're
quadrant.
doing a negative.
But we want the negative of that. The negative of tangent in this quadrant is negative. Because tangent's positive down here, right?
Yes.
So I want the negative of positive.
Negative.
Is what? Negative.
Oh.
That's how we get a -1.
Okay. I just didn't-
Because tangent of this is y. So I want the negative of 1. -1. Right,
But you're multiplying
right.
by negative.
This right here is 1. All right, but I'm multiplying by negative.
In the third quadrant. But that, yeah, but it's. it makes sense, yeah.
Because originally, we're dealing with this negative angle, which means we would have wound up here. But it's easier to deal with positive angles. than it is with negative angles. And so I find out what the tangent of this angle is.
That's where you get off problem.
So if I was taking the tangent, let's say, of 27 pi over 4, right? 27 pi over 4. Then that's 24 pi plus 3 pi over 4. So now I have 6 pi plus 3 pi over 4. So that means I would go around 3 times and then I'd go to here. And then the tangent there is negative. So that would tell me that the tangent of 3 pi over 4 is a -1. But if it was like over here, it was a -27 over 4 pi, then I would have a negative sign out here. So I want the negative of the -1, so it makes it positive. Well, that means the original angle went down to here. Right, we're dealing with a positive, and then we're going to change the sign appropriately. Because of that negative outside of the tangent, once I bring this negative sign out, I'm going to take the tangent of this angle and change the sign. So whether it ends up being in a negative place for tangent or a positive place for tangent, I'm going to change the sign. That's the nature of odd functions. Where with an even function, the cosine of a negative angle is the same as the cosine of a positive. So if I was doing the cosine of a -29 pi over 4, then it'd be the same as the cosine of 29 pi over 4. Because cosine in the second and third quadrant are the same. They're both going to be negative in these two quadrants. Right. Such odd fellows. And so that's going to be the sine of -30, the negative sine of 30, which gives us a -1/2.
It's like we're switching the meaning of the negative sign.
No, no. We're not. We're using the definition of odd functions to change our sign. Right. Well, it's like if we did the sine of 150 degrees. Or the sine of a -150, which is the negative sine of 150. Well, 150 takes us over here. And the sign is positive over here. But we want the negative of that. So it'll be, so it'll be the negative sign of 150. So that means it'll be what, a negative 1/2 instead of a positive 1/2 because of the odd nature of the function. Negative pi, negative 150 takes you into this quadrant, which sign is negative down. So the sign of the positive is the same as the negative of the sign of the negative. Cosine of a negative angle is the same as the cosine of its positive. The cosine of opposite angles are the same. And we already discussed cosine and tangent. They broke it down same way as did. And there we have it. Good time waste. So I'm gonna quit there. So we're gonna start on section 6.4. And if you think it's been hard so far, it just got worse. But these are graphs. That's all. Wait till we get to polar coordinates. Polar coordinates. That's where you talk about the radius. So if I have 3 pi over 4,
Is it like
then the radius is 3 pi over 4 is this angle. And so I go 3 units out on this angle. So 1, 2, 3. So a polar coordinates. Well, with this, there's yeah, they're pretty much codependent because you need both to find that point. And you don't have you start with one or you start with the other one, doesn't matter. But we're not there yet. So. Okay. If y'all have questions, now's the time to ask. If otherwise, you're free to go.
Is it gonna be a different channel, a whole completely different channel, or will it be that same channel where you post the YouTube video? Because
So y'all are, is everybody having troubles accessing those videos?
you only have August 24th up on the channel that I see, but I don't know if there's a different. Are you uploading to 2 different channels?
No.
No.
So there should only be 2 videos. There should be 2 videos.
August 24th is the only one that shows up.
Okay. No, they're published and I put them as public. So
Yeah, that's where.
no,
that's the
I was
idea of
trying to
different
change
channels.
the college algebra to the pre-calculus.
That's what you said.
Well, I'll go in there and see what I can do to fix it. You too. And I need to call IT and tell them that this is all screwed up.
like every class I've gone into, they've had to call IT in.
Well, there's. Yeah, I'm gonna go in there and look at those problems. I should be able to reduce the number of questions. Especially with the angular motion, the angular stuff.
How much time do you have before you grade all that?
When the exams pop up.
Okay, so September 24th, I saw the first one.
Yeah.
Alrighty, so we got some time to make sure everything's nice and done.
On the last one, algebra into pre-calc, there was like some nice working on type examples. I'm not able to find those. Are they there? The homework?
What do you mean, like, view example?
Yeah.
Yeah, you go down there, they're right there. If you go to my lab and then you go to the question, it'll say solve the answer, view example, and like some other option. And then view example won't show you how to work the problem. It'll give you a different similar problem. And it'll kind of show you what to do. You go to my lab.
You have to get it wrong first, or
No, you don't have to answer it. Just view example, and it'll show you another one that looks exactly like it. It'll use the same process. But then there is the help, or just like help me answer.
Y'all take care. Oh, my Zoom meeting screwed up. There it is.